Good morning students. Welcome to our online video class of chemistry. In previous section we had discussed about laws of chemical combinations. Today we will discuss about Dalton's law and atomic mass.
Atomic theory originated as a philosophical concept in ancient India and Greece. In 5th century BC, Democritus proposed the matter is consist of indestructible indivisible unit, that is called atom. The word atom was originated from the Greek word atomos, which means indivisible. And the word atomos was proposed by philosopher Democritus. And the idea that the matter is composed of numerous tiny particles, that is called atom, was first proposed by early philosophers. However, it was only in 1808 what John Dalton could give a scientific basis to this old hypothesis by proposing his famous atomic theory known as Dalton's atomic theory. Dalton's atomic theory was the first attempt to describe all matters in terms of atoms and their properties. And this theory is based on law of chemical combinations, mainly of law of conservation of mass and law of constant or multiple proportions. Let us study now what are the main postulates of Dalton's atomic theory now. First postulate is matter is made up of extremely small particles called atoms, which cannot be divisible into simpler units. It is indivisible. Consider an element, that is carbon, and it is made up of extremely small particles, tiny particles, that is called atoms. If we take one of this atom, it is possible to divide this into simpler units? It is difficult to divide this atom into simpler units. That is the first postulate. Atom is indivisible. Next postulate is all atoms of given elements have identical properties, including identical mass, size, etc. Atoms of different elements differ in mass and size. For an example, gold, aluminium foil, diamond. Diamond is composed of fully of single element, that is carbon. In all that, every single atom of an element, such as gold, aluminium, and carbon, is same as every other atom of that element, including their mass, size, properties, etc. And the atoms of different elements differ in their mass, size, properties. For example, let us take carbon, nitrogen, and oxygen. All these are different elements and made up of different kind of atoms. Then carbon. What is the mass of carbon? That is 12. And nitrogen is 14. And oxygen is 16. All these elements have different mass. What will be the size? Along the period of the periodic table, the atomic size decreases. Therefore, carbon has large atomic size than nitrogen and oxygen. That is the second postulate. Atoms of different elements have different atomic mass and size. Next postulate is compounds are formed when atoms of different elements combined in a fixed ratio. For example, formation of water molecule. This we already studied in previous section. Two molecules of diatomic hydrogen combined with the one molecule of diatomic oxygen gives two molecules of water. Then the ratio between hydrogen and oxygen is 2:1. From this example, we can conclude that a compound, that is water, is formed by combining two atoms of different elements, that is hydrogen and oxygen, in a fixed ratio 2:1. Next postulate is chemical reactions involve reorganization of atoms. These are neither created nor destroyed. Let us understand the postulate using an example. Example, the reaction of hydrogen and chlorine to use hydrogen chloride. Here only a simple reorganization or rearrangement of hydrogen and chlorine take place. Hydrogen and chlorine just simply rearrange or reorganize to give hydrogen chloride. Here there is no formation of new atoms and no destruction of any atoms. What is the postulate? Chemical reactions involve reorganization of atom. These are neither created nor destroyed. I think from this example you might have understood what is the postulate. The main drawbacks of Dalton atomic theory are it does not account for subatomic particles. As we learned that what is the first postulate? Atom is made up of tiny particle and which is indivisible. But it can be further divided into simpler units. That is subatomic particles, protons, neutrons and electrons. It does not account for subatomic particles. Next drawback is it does not account for isotopes. We have learned that according to Dalton's atomic theory, atoms of same elements have same mass. But it's now found that atoms of same elements can also have different masses. That is isotopes. You have learned about isotopes. What are isotopes? Isotopes are the atoms of same elements having same atomic number, different mass number. These are the isotopes of hydrogen. H11, protium, deuterium and tritium. Here atoms of same elements have different masses. From this we can conclude that it does not account for isotopes. Another drawback is it does not account for isobars. According to Dalton's atomic theory, atoms of different elements have different mass. What is isobars? Isobars are the atoms of different elements have same mass number. Examples of isobars are potassium, calcium. Both are different elements but have same mass, that is 40. Therefore, we can say that it does not account for isobars. Atomic mass is the mass of an atom. On discovering that the matter is made up of atoms, scientists' attention was shifted towards how to find out atomic mass of an atom. We know that atom is extremely small particle which cannot be divisible. So scientists could not able to determine the actual mass by weighing it. Today we have mass spectrometry to determine the atomic mass of an atom accurately. But in the 19th century, scientists could determine the mass of one atom relative to another. For that, they took hydrogen as a standard for determining the mass of other elements. Because hydrogen is the very lightest element which has atomic mass 1. But it was later found that hydrogen atom is unstable element. But later it was found that hydrogen is very unstable element and it has isotopes. Isotopes are the atoms of same elements which have different masses. So it is difficult to determine the atomic mass of other elements by taking hydrogen as standard. However, present system of atomic masses is based on carbon-12 as the standard. All other mass is determined by relative to the carbon-12 isotope. Carbon-12 is the one of the isotope of carbon and it is represented by C12. The International Union of Pure and Applied Chemistry accepted this scale to be used for expressing atomic and molecular masses in 1961. In the scale of atomic masses, the carbon-12 isotope has been assigned an atomic mass of 12 atomic mass unit or AMU. And the atomic mass unit or AMU is defined as a mass exactly equal to 1/12th of mass of one carbon-12 atom. Or we can say the mass equal to 1/12th of the mass of a carbon-12 atom is called one atomic mass unit. 1 AMU equals 1.66056 into 10 to the power of minus 24 gram. AMU means 1/12th of the mass of carbon-12 isotope. And mass of an atom of hydrogen in grams equal 1.6736 into 10 to the power of minus 24 grams. Therefore, in terms of AMU, the mass of hydrogen atom equals mass of an atom of hydrogen divided by 1 atomic mass unit, which is equals 1.6736 into 10 to the power of minus 24 grams divided by 1.66056 into 10 to the power of minus 24 gram, which is equal to 1.0080 AMU. This is the atomic mass of hydrogen. Similarly, the mass of oxygen atom equals 16. Atomic mass would be 15.995 AMU. At present, AMU has been replaced by U, small letter U, which is known as unified mass. When we use atomic masses of elements, in calculation we actually use average atomic mass of an element. Next we are going to discuss about average atomic mass. Average atomic mass. Many naturally occurring elements exist as more than one isotopes. When we take into account the existence of these isotopes and their relative abundance, percentage occurrence, the average atomic mass of the element can be computed. Average atomic mass can be calculated using the formula average atomic mass equals atomic mass of one isotope into its abundance plus atomic mass of another isotope into its abundance, all divided by 100. Let us look at an example for average atomic mass. Observe the table. The table contains isotopes of carbon, that is C12, C13 and C14, and their relative abundance and atomic mass is given. How do we calculate average atomic mass? Atomic mass equals atomic mass of an isotope into relative abundance plus atomic mass of another isotope into relative abundance. Then using the formula, we can calculate average atomic mass. Then average atomic mass equals 98.892 into 12 plus 1.108 into 13.00335 plus 2 into 10 to the power of minus 10 into 14.00317 all divided by 100. We get 12.011 U. Molecular mass. Molecular mass is the sum of atomic mass of an element present in a molecule, and it is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. Let us do an example. Methane. What is the molecular mass of methane? How do we calculate the molecular mass? In methane, there are 1 carbon atom and 4 hydrogen atom. Atomic mass of carbon is 12 into 1 because there is 1 carbon atom plus 4 into atomic mass of hydrogen 1, which is equal to 12 plus 4 equal 60 U. Molecular mass. In the case of ionic compounds, for an example, sodium chloride, the terms molecular mass loses its significance because no definite molecule exists in such compounds or do not contain discrete molecule has their constituent unit. It may be noted that in sodium chloride, 1 sodium ion is surrounded by 6 chloride ions, or it will be 1 chloride ion is surrounded by 6 sodium ions. And the formula mass is obtained by adding the atomic mass of all the atoms present in the empirical formula of the compound. Then formula mass of sodium chloride equals atomic mass of sodium plus atomic mass of chlorine. Atomic mass of sodium is 23.0 U plus atomic mass of chlorine equals 35.5 U, which is equal to 58.5 U.